unit testing as a software development technique where you divide your software up into small isolated units and then you write automated tests for those that verify that each unit works as expected. My main motivation for doing unit testing is to keep complexity from overwhelming me. We're going to look at how a piece of code always starts out simple, but eventually grows in complexity until it is too much to keep in our heads. I am MPJ, and you are watching Fun Function.
Nothing your computer is your friend. It is your friend.
So today's video is completely focused around why we do unit testing. So we are actually not going to be writing any proper unit tests today. We're not going to be at all focused on the what unit testing is or how we do it. We're going to start with why. And I want to start in this way because unit testing can be daunting. It can be daunting to learn, it can be daunting to do when you're under pressure, like a tight deadline, you just want to get your software out, or on days when you're just feeling lazy. In those situations, it's very important to know why we are doing unit testing, where it comes from, and what we're trying to achieve with it. Alright, so let's imagine that we are running an online pet store that specifically targets people who own small dragons. In the checkout and some other places, we are going to display the order total, a sum of all the items that we currently have in our shopping cart. Somewhere in the code base, we're going to have this function called order total. That function is given an order and it outputs a total amount of all the items that are contained in that order. Alright, success. Let me walk through this code for you. So we have this example order here called sum order. This sum order has an item property with an array of dragons that have a name and they have a price. The dragon cage is slightly more expensive than the dragon food. It costs 800 things. And here we have the star of the show, order total. It takes an order and it accesses the items property here, and it reduces all those items down to an order total by summing the price together. And then we call the order total with some order here, and we get a result, and that is 108, which is 800 here plus 808. Did I say 108? 808. Huh. Hello, MPJ, your emotions here. I have not seen reduce before, and that makes me feel a little bit uncomfortable. I would rather use something that I'm used to, like a for loop. Hello, feelings, benefits here. It's completely normal to be afraid of new things, but remember that new things become less scary the more you use them, and reduce is super useful, and I really urge you to learn it. It will really change the way you think about things. We actually made an episode about that you can find by clicking there. Excuse me for chiming in here. I would just like to this here. I would like some alternate. Yeah, this is a bit nicer. Now it looks like a table, right? That's nice. Okay, that looks beautiful in that specific case, but it would break in a linter in any real project. That is just indentation that is useful in just this specific case. That's valid points, but this video is about unit testing. Can I focus on that? Alright, fine. This example to me seems very exemplary. This order total function here, this is already a cleanly separated unit function. It's in real code, things tend to be a lot more intermingled. I feel like this is just a very theoretical example. Yes, this doesn't feel like real code to me. Sure, this is absolutely an oversimplified example, but this again is it's just an introduction to unit testing. Can we look at what the code looks like right now and what we could learn here? All right, we can do that. I feel like this code order total, it doesn't need tests. It doesn't feel like it needs tests. It's very simple. Even with reduce, which I'm uncomfortable with because it's new, it doesn't feel like this is enough logic to warrant having an automated test suite. That seems like shooting a fly with a bazooka. Well, sure, it looks like that now, but even the most horrifyingly complex function starts out in a simple way. It's kind of like what's the expression? Boiling a frog? Or do you boil a lobster? Is it a lobster? You put it in cold water and then you just increase the temperature until... You know, that's a good point. Let's try adding some complexity to this code. Let's invent some. Let's add quantity. Okay, so I've added a little bit of complexity. What can we talk about this? I feel like, well, I'm still not afraid of this code. It still seems very manageable. Maybe unit tests are a waste on simple functions like this. Or maybe that's a good point. Maybe they could be beneficial for us to pick our battles and not do unit testing on every single function and just save the time and not do unit testing on simple functions like order total here. People, you have to think about the old Swedish proverb. You have to think longer than your nose goes. That's not a good translation of that proverb. My point is that complexity is going to grow over time. What we see here, this is just one of 100 steps. Fine. Let's try that hypothesis and just add even more complexity. Let's add shipping, and if the order total is above $1,000, then shipping is free. So what did we do here? We extracted the total, like we started filtering the items first before doing the summing. So we sum only items that aren't shipping items, and then we find the shipping items in the array, and then we calculate the shipping if to be 0 if total items value is above 1,000, or the shipping to be the price of the shipping item otherwise. And then we add the two together, and then we eventually get the result down here. Now this is what I'm talking about. Things are getting more complicated now. Now that we added a conditional statement here, our code has multiple execution paths. Before, when we just had the price and we just had the quantity, our code just had one execution path. But now we have two. One where the order is large and we waive shipping, and one where the order is small and we charge shipping. Okay, so I think I'm starting to get your point. This code definitely got a little bit scarier now that we added shipping. Yeah, and I think I know why. It's because previously, before we added shipping, we could express the entire logic, or like what order total did, with just the sum order example. We had one example that expressed the entirety of what the function could do. But now, the example call, like sum order, can only tell half of the story. which is in this case that it's a big order. But if I change this to be quantity 1, we are now on the small order case. So this time it adds shipping, but the example can only express one of the forks in the road, so to speak. Yeah, I mean, I still feel pretty confident about this code. It's that's because I kind of executed this in my head while we wrote it. So it's only one other fork, one other branch in the logic. So it feels kind of manageable to keep in my head. But exactly. And let's say that we started adding more steps to the complexity over time. Like say that we added taxes or immaterial goods that require no shipping charges. Yes, then you can probably see how this would eventually get to a point where it's just too much for your brain to handle. All right, that makes sense. But if our goal is to think about less things at the same time, then couldn't we start breaking this thing apart into smaller functions? Breaking bigger functions into smaller isolated functions that are responsible for just very isolated things, that's generally a very useful tool, but I don't think it makes sense in this case. Order total seems like a pretty good unit to me. It seems like an isolated problem. In order to break things up into small functions, you actually have to be able to also break up the conceptual problem. Like if you just start extracting things out into lots of tiny functions, you're not really breaking the problem up so that you can think about it separately. You're really just spreading the problem out over multiple places so that you have to diverge your thinking even more. I think that you actually have to accept that even when a software module is small and isolated and minimal, it is probably still too big for you to keep it all in your noggin. Okay, yeah, but it feels like... Doesn't that mean that I'm dumb? It feels like a rockstar, super smart programmer would be able to keep this easily in their head. I understand where that feeling is coming from, but that kind of thinking just doesn't scale. If we have a software industry where the average developer can't build software of reasonable quality, then we are doomed as a world to have shitty software. And even if you are a software company that can afford and is capable of hiring the very best of the best, even their brains is going to get overwhelmed by complexity at some point. It's like with juggling. I can juggle 3 onions, okay? And maybe you are better at juggling. Maybe you can juggle 5, and the world record is 11 balls, but nobody is even close to handling 15 balls. All right, so what did we learn here? Let's summarize. Code always feels very simple from the start, but it doesn't stay simple. It grows and grows and grows into multiple use cases. Too many to keep in our heads. All right, I want to see what unit tests look like and if they can help with this. Which is what the next episode is about. You have just watched an episode of Fun Function. I release these every Monday morning 0800 GMT. If you are watching from the future, you can find next Monday's episode here. Otherwise, you can subscribe here so that you don't miss it. If you are for